This is a key to the worksheet on simplifying radicals. And so in this worksheet, this is topic 19, and this is the worksheet called Extra 4. And so you're going to simplify radicals. Notice you have square roots involved, and then there's a cube root involved as well. So if you look at make sure you read the directions. It says simplify each of the following. Show that you are using the product rule and or the quotient rule to receive all points. Just don't write down an answer. So I did give you sample work to look at. So if you look at number 1, you have the square root of 44. All right, now remember the direction says show that you are using the product rule and or the quotient rule to receive all points. Okay, so basically you'll notice that you're dealing with square root. 44 is not a perfect square. But remember, with regards to perfect squares, so your perfect squares are, let me go ahead and get another sheet of paper. Your perfect squares are, so your perfect squares, and this was reviewed in a previous lesson as well, but the first perfect square is 1 because 1 squared is 1. So if I take the square root of 1, I get this base back. So the next perfect square would be if I take 2 and I square it, I get 4. So these are your perfect squares right here. And there are an infinite number of perfect squares. So if I take the square root of 4, I get the base, which is 2, because 2 squared is 4. The next one is 3 squared is 9. So that's how you get your perfect squares. You just take your positive integers and you square them. So the next one is 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36, 7 squared, which is 49, 8 squared, 64, and so on. Okay? So you get your perfect squares that way. And there are an infinite number of those. Okay, so if I look at number 1, okay, so 44 is not listed as a perfect square. But you can still simplify that because there is a perfect square in here that is a factor of 44. Now, 1's a factor of all numbers. Okay, so we're not even going to look at 1, but you want to use the largest perfect square, the largest of these that is a factor of 44 that will go into 44 evenly. And so obviously you can tell that it's 4, right? So 4 would be the largest perfect square. So the directions that said this, remember the directions. Direction says show that you are using the product rule. So this will be the product rule here. The quotient rule will be with something like 5 and 6. All right, so the product rule. So you're going to say this. So this is what I needed to see. And let me go ahead and actually do it underneath. Okay, all right, so 4 is a perfect square. So you're going to say this. You're going to say the square root of 4 times 11. And so the product rule, because 4 times 11 is 44, and 4 is the largest perfect square. So you want to write this as the largest perfect square. So write the factor that goes here is a perfect square that goes into 44. All right. So you don't want to use. You see, you did not want to use. Let me remind you. You don't want to say. You want to say the square root of 2 times 22. You don't want to do that because 2 is not a perfect square and 22 is not a perfect square. So those are not perfect squares. So that's not going to help you at all. All right. Now you can use that and go further, but then that becomes more complicated. So what you want to do to simplify the square root is to make one of those factors a perfect square. See, these 2 times 22 is 44, but 2 is not a perfect square, nor is 22. All right, so you want to use a perfect square. Always think about, I need to use a perfect square. If I'm trying to simplify a square root, I need to try and use a perfect square. So now what we're going to do is I'm going to use the product rule. So the product rule says that will be the square root of 4 times the square root of 11. And so therefore I can say my answer. Square root of 4 is a perfect square. The square root of 4 is 2. So the answer is 2 square root of 11. So there's the answer. Okay, and that's your work. Okay, number 2. Number 2, we have this. We have 2 times the square root of 75. So again, I'm dealing with square root. 75 is not a perfect square. And so I want to look for a perfect square. Remember, one's a perfect square that goes into all of them, so let's not worry about one. So can I find one of these perfect squares? And the largest one, always use the largest because it makes things a lot easier. The largest perfect square that will go into 75. And obviously you saw that it was 25. So what you're going to do now is going to rewrite this as 2 times the square root of 25 times 3. So remember, just like we did this, always always write the factor of the perfect square first. It makes things a lot easier. But this has to be a perfect square. This has to be a perfect square. And now using a product rule, I can write this as 2 times the square root of 25 times the square root of 3. And the square root of 25 is 5, right? So I get 2 times 5 square root of 3. So the answer is 10 square root of 3. Okay, so there's your answer. And for the work, now quite a few things here. You didn't have to, you could have done just giving me this for the work. All right, so you didn't have to actually do this little part here. Because most of you can look at this and say, well, square root of 25 is 5, 5 times 2 is 10. But I had to see some work, and the work that I needed to see was this. So it's important you read the directions. Direction says, show that you are using the product rule. And so I'm using the product rule. Okay. All right, number 3. Number 3, we have -4 times the square root of 125. So that one's not a bad one either because notice just like with 75, the last digit's 5, right? So the only possibility for 75 that you could have tried in terms of perfect square was 25. And the same thing here. So let's try 25. So you're going to write this as -4 times the square root of 25 times 5. Okay. Notice I use a perfect square. Always make sure you're using a perfect square. If you're not, it's going to make things so much more difficult for you. And so this, but using a product rule, I get -4 times the square root of 25 times the square root of 5. And again, so that will be your work. And then your answer would be this right here. What goes in here, that will be your answer. And so most of you can look at this and say, hey, that's going to be 5. Square root of 25 is 5 because 5 times 5 is 25. 5 times -4 is -20, right? Square root of 5. And so if you wanted to put in the step, you could. So this would be -4 times 5 square root of 5. And then you get -20 square root of 5. Okay, number 4. Number 4, you have the cube root of 135. The cube root of 135. Okay, so notice that you may say, well, I'm going to look at my calculator and see what the cube root of 135 is. Well, first of all, if 135 is not a perfect cube, this time we're talking about perfect cubes, not perfect squares, because this is cube root. Notice that when I take the cube root of 135, I get a decimal. So that means that 135 is not a perfect square. But let's go ahead and remind ourselves what are perfect squares. So perfect cubed. What are our perfect cubes? Our perfect cubes. So just like we did the perfect squares, you're going to take 1 and you're going to cube it this time. So 1 times itself 3 times is 1. So these are your perfect cubes right here. Then the next one will be 2 cubed, which is 8. So 8 is a perfect cube because the cube root of 8 is 2. 2 times 2 times 2 is 8. The next one is 3 cubed, which is 27. Cube root of 27 is 3 because 3 times 3 times 3 is 27. The next one, 4 cubed, 4 times 4 is 16. 16 times 4 is 64. So it's getting a little bit more complicated to figure out by hand. The next one, 5 cubed, is 5 times 5 is 25. 25 times 5 is 125, and so on. All right, so these are your perfect cubes, and there are an infinite number of those. Obviously, you can see you can keep on going for infinity. And so for 135, where we had the cube root of 135, you want to go through there and not even looking at one. You want to go through there and see which one of these is a factor of 135. So what I would do is I would just take, let's say the first one, 135 divided by 8, right? Oops, sorry. 135 divided by 8 gives us, oops, I made an error. Okay, let's do it again. 135 divided by 8 gives us that. So obviously that didn't work. Let's do 27. 135 divided by 27. Hey, there it works, right? 5. So the perfect cube that goes into 135 is 27. All right, so you're going to write it like this now. You're going to say this. You're going to say, so this will be the cube root of 27. Say 27 times 5 is 135. So 27 times 5. And then using the product rule, I get the cube root of 27 times the cube root of 5. Make sure you put the index. If you leave the index off, it's now understood to be square root, and you're not going to get all your points. And so this is your work, and now you can write the answer. The cube root of 27 is 3, right? Cube root, so if I take the cube root of 27, I get 3 because 3 times itself 3 times is 27. So cube root of 27 is 3, so the answer is 3 cube root of 5. All right, let's go to number 5. Now, in number 5, you have the square root of 72 divided by 100. Now, be a little bit careful here. Some of you are going to probably want to simplify this because they're both even. Don't do that with this one. Do not do that with this one. Because see that 100 right here? That's a perfect square. So I know my denominator is going to be 10. So don't reduce this because it'll make things a lot more difficult. All right, so the way I want you to do this is this. So let's do it right here. So this will be the square root of 72 divided by the square root of 100. All right, so using a quotient rule for radicals. Then notice that 72 is not a perfect square, but besides 1, what is the largest perfect square that goes into 72? The largest one now. Always choose the largest. All right, so if you just go through there, notice that 72, what you may say, well, I'm going to divide 72 by 4 and see what happens. Okay, that's fine. You can do that. You have access to a calculator. You get 18, right? But notice that 18, well, I want you to notice this, that 4 is not the largest perfect square. 4 is not the largest. Because notice, what other perfect square goes in 18 now? Well, there's 9, right? Okay, so you may say, all right, 9 times 4 is 36. All right, so let's try 36. So let's try 36. So you're going to say, what was it again? It was 72. So you're going to say 72 divided by 36, and that's 2 now. And 2, the only perfect square that goes into 2 is 1. So you're done. 36 times 2 is 72. You found the largest. The largest is 36. So you're going to do this. So you're going to say, all right, so that's going to be the square root of 36 times 2 divided by, now I'm going to go ahead and simplify square root of 100, which is 10. And then so this becomes the square, now, so this becomes the square root of 36 and square root of 2 divided by 10. And the square root of 36 is 6, right? So I get 6 square root of 2 divided by 10. Now at this point, this is where you would reduce, because I can reduce to 6/10 here. So that will become 6 and 10 are both divisible by 2. So that would be 3 square root of 2 divided by 5. So there's your answer. Okay, there's your answer. And then for the work, you just need to show something like this for the work. You could have skipped that part here. You're going to go directly from here to here. All right. So, but you got to reduce. Make sure you reduce. Okay. So, now what I want to do is remind you about 72. And I'm going to do this here so I can leave this room for number 6. But I want you to notice something. So let's talk about square root of 72. So remember I said always use the largest perfect square, right? Because it saves you a lot of steps. So let's suppose that some of you did not. Suppose that some of you said, well, just like we did earlier, we said I'm going to see if it's divisible by 4. And it is, because notice 72 divided by 4 gives us 18. So you may say, well, I'm going to write this. I'm going to use it for a perfect square. I'm going to use 4. Okay, no issue with that. I have no problems with that. But you got to remember now. You got to remember. So at this point, you're going to say, now I'm going to use the product rule. So it'll be the square root of 4 times the square root of 18. The square root of 4 is 2. So you get 2 square root of 18. If you say that's the answer, you don't get all your points because you know that simplified, the square root of 72 is 6 square root of 2, right? That's what the square root of 72 is. And so it's not 2 square root of 18. What you have to notice is that, hey, this 18, I can simplify that further, the square root of 18. Because what perfect square goes in 18? Well, 9. So then this becomes 2 times the square root of 9 times 2, right? And then so that becomes 2 square root of 9 square root of 2. And the square root of 9 is 3. So that's 2 times 3 square root of 2. 2 times 3 is 6. I get 6 square root of 2. And that's what you see here, right here. Okay? So be careful. If you don't use the largest perfect square, you have to use a perfect square. That's the only way you can simplify. But if you don't use the largest perfect square, you have more steps to do. Okay? All right, so that's why we keep telling students to make sure you use the largest perfect square. It makes things a lot easier for you. Okay, let's look at number 6. In number 6, we have the square root of 274 divided by 4. So that is very similar to number 5. So notice that 4 is a perfect square. So don't simplify this. Do not simplify this. You don't know how to deal with the outcome at that point. So all you know how to deal with is where the denominator is a perfect square or a perfect cube, where the denominator simplifies into an integer. So do just like we did this one. You're going to say the, and that's supposed to be a 5, by the way. Sorry. Well, anyway, you couldn't simplify this anyway, right? 275 divided by 4, you can't simplify that anyway. So, but if it was 274, you could. But you can't. So there's nothing else you can do except to write it as 275, the square root of 275 divided by the square root of 4. Okay, now let's talk about the square root of 4. So we know the denominator is 2. That's no issue. I know what that is. Let's talk about the square root of 275. So what is the largest perfect square that goes into 275? Now notice the last two digits, 75. So you know you're going to try 25, right? Oops, sorry. You're going to try 25. That's what you're going to do. All right, so let's use our calculator and say, well, 275 divided by 25 equals 11. I'm sorry, I made that up. Yeah, that's right. Okay, 11, right? So 275 divided by 25 is 11. So 25 times 11 should give us 275, correct? All right, so the way I'm going to rewrite this now is this: the square root of 25 times 11. And then rewriting this, that'll be the square root of 25 times the square root of 11 divided by 2. The square root of 25 is 5, so you get 5 square root of 11 divided by 2, and you cannot reduce this, so you're done. That's the answer. All right, so this is your answer. That's the answer, and this will be your work. Okay? All right, so that is the key to the worksheet dealing with radicals number 4. All right, so that will be the key to that.